I'm Chris Palmer, 3D Dock Applications Engineer at Faro, and welcome to the second part of the PointSense Revit tutorial videos. In this video, the first thing we're going to look at is preparing a point cloud for automatic modelling using the Point Cloud Preparation tool. We will then look at the Fit Walls command and also the Align Walls command. So I'm just going to open up a demonstration project inside Revit now. As you can see, we have a colorized point cloud, and it is a 1960s office building of traditional construction. If we just go to a predefined section that I've already made, you can see the building's on split levels, and I've already taken the liberty of creating some actual levels for us to work from. If we just go to the ground floor and zoom in, one very important thing that we need to remember when using the Prepare Point Cloud function is that we need to set the clipping range of the view. We can do this by enabling the clipping box, selecting it and clicking Edit Crop. We are then going to delete that crop region area and create a new one around the outside of the building. This is very important because the Prepare Point Cloud function will search the entire radius or the entire extent of the clipping region. So now we've changed that, the second thing we're going to do is just to hide that off, and then we're going to go to our view range and we're going to edit the view range. We're just going to lift the base of this view range up very slightly, about 600mm, just so we've got rid of some of the floor area and we've got a nice clean view that we can now run the Prepare Point Cloud tool on. So if I now go to my PointSense tab and I click on the Prepare Point Cloud tool, we are now going to be presented with a new dialog box. This dialog box is going to tell us our lower level offset, which is 600mm, and our upper level offset, as well as the clip box size. It's going to give us the option to prepare the point cloud and insert it hidden into this view, insert into this view and hide the point cloud, or to create a copy of this view and locate it there. So I'm just going to press start now. Now you can see the speed that this is going. This is not really realistic. This will take about 4 or 5 minutes depending on the size of the point cloud you have and the crop region. This actual image that you're watching now took about 5 minutes to generate. However, obviously I've speeded this up during the video so that we could see the entire process. Essentially what's going on now is an orthographic image has been generated, which we can then insert into the project. So I'm just going to go now and open up my ground floor prepared view, which has been added into my project browser there, and as you can see, the Prepare Point Cloud function has basically created an X-ray type image to give us a much better definition of the main surfaces which we can see on the plan. So if we just open up the original point cloud view and tile these two together and we just zoom in on a couple of elements, you can see the difference that has been made and how well you can actually now see the edges of the walls, particularly around window openings. We can also see the stairs a lot more clearer now. And if we just zoom in around some of these mullions and things there, we can see door openings and things are a lot clearer. So now that we've prepared our point cloud, we are going to use the Fit Wall command. To do this, I go into Object Tools and Fit Wall command. I then need to set my top constraint for my new wall, which I will use wall plate level, and I press Start Fitting. I'm then going to select a point at the start and the end of the wall of a uniform thickness, and I will be presented with the Fit Wall selection screen. As you can see, the two red lines here have generated a measurement. The measurement of the detected thickness is 400mm, and it is giving us a selection of walls which are loaded at the project and giving us a delta measurement away from the detected thickness. So the closest fit we have is a 440mm wall. We also got this screen which we can use to determine the rounding factor we allow the software to use, and we can cancel and repeat that command. We can insert the selected type, or we can insert the selected type with an adjustment. If we do this, this will edit the structure layer of the selected wall type with a rounding factor of 5mm and insert that wall type. However, what we are going to do is we are going to create a new wall type, and we're going to call this survey wall. And for people like surveyors or other people modelling point clouds, often you will not know the makeup of the actual wall itself. So in this instance, what we're going to do is we're going to create a survey wall type with the material set as default wall. So we set that from this list here, click OK, and we're going to leave the thickness at 100mm for now. Click OK. Now we're going to go back into our point sense command and use the fit wall command again. So I'll set my level to top constraint to wall plate level again and start the wall fitting. Click the start of the wall and click the end of the wall. The algorithm runs again. Now what we're actually going to do this time is we're going to choose our survey wall, which is set at 100mm thick currently, and we are going to insert the selected type with an adjustment. What this will do is it will add the extra 300mm in to the wall construction type and give us a new wall type with a suffix of the actual detected measurement. So if we select that there, you can see on the left hand side we have basic wall survey underscore 400mm. So if I just open up the 3D view and the plan view now so you can see this, we have the wall inserted into the point cloud and the top constraint is the wall plate level. Okay, so what we can do now is we can go back and run that start wall fitting command again, select 2 points and generate another wall thickness. Now this time we can actually go into our last used types column, select the survey wall again and insert that selected type with an adjustment again. Now we are using the same wall type, but we are generating a new wall type with a suffix of the detected thickness. So what we can do obviously now is we can go around the project and start to insert these walls very quickly. For the time being, we are not going to worry too much about the actual wall joins because that will be the next step. So we're using the last used types again and inserting those selected types with an adjustment if necessary. So I'm just going to go around now and have a look at the back of this building, and we can locate another wall and we can fit another wall type here. So back to the fit wall command. Notice I'm just doing the external walls for now, so I'm leaving the wall plate level as the top constraint. So we can go and we can use our survey wall in the last used types and insert that with an adjustment. So I'm just going to close off the rest of the perimeter walls now. The detected thickness in this instance is 675, however we will use our survey wall and that will automatically generate. We'll close off this corner. We can insert the selected type with adjustment there. And now we'll probably look at some of the internal walls. If we zoom back out again, close down the 3D view there and just maximise this window. So what we will have to do now is just create a new level to create a new top constraint. So if we just cut a section through this building and zoom in, what we're going to do is just use the standard Revit command to create a new level, and I am going to rename that first floor, and this will be the top constraint for our new internal walls when we start fitting them. So if we go back to the floor plan, and we go back to the Point Sense tab and use the Fit Wall command. Change the top constraint to first floor, and we can start again now just to fit some of these internal walls. We're going to use the survey wall type again, and we're just going to work our way around, inserting the survey wall type with an adjustment if necessary. Notice here, because some of these wall types are standard sizes, once we've generated the 75mm type, we could just insert that as standard. So go around again, insert with adjustment. So obviously, like I say, you notice we are not actually joining these walls for the time being, because that will be the next step. So we just need to focus on getting the actual walls into the building. Just close this one off here. We don't have to be too careful with our picks. We have about a 500mm radius, which can be changed in the settings if we need to change that. So just insert that selected type again. Insert that selected type again there, and we will just put a couple more in here just to give us a good overview of the floor plan. Okay, so the next step when modelling using the Point Sense plugin is to use the Align Walls command to join these walls together. So the first thing I'm going to do, just to demonstrate this now, is to create some angled dimensions between the walls as they are. As you can see, all of these walls have been put in and they are not straight, they are not 90-degree angles. Point Sense will actually insert the walls at the angle that they are shown in the point cloud. So what I'm just doing now, I'm just dropping these angled measurements in because the Align Walls command will give us the option to actually reorientate some of these walls to a reference system of our choice, with tolerances of our choice, and these angles will actually update. So if we just leave this as it is now, we can go back to our Point Sense command tab, and we can open up our Align Walls command. So when we have the multiple wall selection ticked, we can go now and highlight multiple walls that we wish to align and join, and click on Finish. This is going to now open up our Align Walls screen. In the options area down here, you can see we have the option to use a user-defined reference system for the joins. We can ignore the user-defined reference system and do this automatically, or we can leave the wall axis unchanged. The user-defined reference system can be determined in the parameters area below here, and we also have the wall list results, which is giving us a deviation from the defined reference system. As you can see, I currently have my increment angles for reference direction set to 90 degrees. We can change that to say 60 degrees and update the results here. Now you'll see those results have updated, very slightly changing, and on the right hand side of the screen you should be able to see those angled measurements changing very slightly as well. The colour coding that we have is to tell us the different reference systems, and also to classify the deviation. So for example, a red result is showing us that this doesn't really match the direction very well. We can change the maximum rotation angle for the walls, and we can change the maximum deviation from the reference system. We can change the max deviation for the wall axis alignment, and we can change the radius that we're going to allow the walls to join, the measurement that we're going to allow them to use. Over in the display color options area, we can choose how the actual results are displayed. So we have show reference systems, show wall axis, obviously the presets show deviation. We can show open unconnected walls, and we can show the original positions. And below that there we also have the output to give us the count for the reference systems and the axis and things like that. So what we're trying to do here is create a user-defined system with tolerances that we are comfortable with, that's going to allow Revit to join some walls that would otherwise be quite tricky to join. So for example, if I just go to leave wall axis unchanged here, you can see in the top right of the screen on the floor plan there is a wall join here which otherwise would not be possible. without creating this user-defined system. If we leave the wall axis unchanged, Revit struggles to join these two walls. So if we just move this window out of the way now, you can see these angle dimensions that we created between the walls have updated and are now either 90 degrees or a lot closer to 90 degrees. So we'll just drag this window back in and we're going to click OK to accept these changes. And now I'm just going to go to my 3D view so that we can have a quick look at this in the 3D space. Obviously the walls are now there located within the point cloud itself. We just navigate around, you can see these. We also have quite a few different walls joined up here now. And if I use the hide point cloud, show point cloud command, I can quickly just remove the point cloud from the view. We can navigate around and we can check to make sure we're happy with all of the alignments. Okay, thank you for watching. In the next video we will look at some of the Virtuserve tools.